Namaste, Namaste everyone. Welcome back to all the classes, refraction classes. You have been watching my class from 5 days or 5 classes. We have been studying about reflection, refraction, effects of refraction like normal shift, lateral shift and all. Hope you are following a little bit of optics at least, and all the derivations what you have done, the concave mirror or convex mirror, mirror formula, F equal to R by 2. You have to just have a refreshing activities every day. You have to write it and learn, otherwise it is of no use. It is simply like watching a movie, you will forget it later, so that is of no use. So please have a refreshing activity every day about all those things. So that it becomes easier once the classes have started, because once the classes have started, you will have no time for revising and all, because everything will run very fast. So if you are spending for 1 hour or 2 hours in a day, per day, I think that will give you a lot of leisure later on. Okay, moving on to this one. Now, refraction through a prism. Now, what is a prism? How does it appear? You might have seen prism. In 3 dimensions, if you look into a prism, prism will have 3 rectangular faces and 2 triangular faces. So if you look into the prism from certain angle, it will look like this. So it will look like this. This is the prism, right? So it will have 2 triangular faces and 3 rectangular faces like this. Now usually prism is used for dispersion, and light changes its direction when it moves from one medium to another. It changes its speed, and the change in the speed for different colors is different. You know it, because all the colors travel together, they will be united in air, and as they travel in air, as soon as they enter the prism, the velocity goes on changing. The change obtained for red color is not the same for blue color. The change in velocity for red is not so much. There is a decrease in velocity for red, but decrease in velocity for violet is too much, so they bend to different angles. That's why Newton for the first time was able to show that white light contains different colors. He made the light to pass through the prism, and different colors started running with the different speeds. When the speed is different, that regularity will not be maintained, and one color lags behind, another color moves forward. If you are standing by the side of a 100-meter track, suppose there are 5 tracks in a 100-meter race, 5 people run, if they run with the equal speeds, and if you stand by the side of the track and observe all the runners, if they will be found in a straight line if they are running with the same speed. Am I right? Suppose they are running with different speed, what happens? You can see one overtaking the other. You will not find them in a straight line. They will be in different positions. Similarly, when the light enters, white light enters any medium, its speed changes. The change in the speed is different for different colors. So different colors start bending to different angles. So now you can see them separately. So we made them to go in different directions. That is what you call dispersion. So you can see the light with different colors. So Newton made the same experiment and showed that white light contains different colors. Okay, so he used prism for doing so. Okay, so it should contain 3 rectangular faces. The light is made to pass through these rectangular faces, because these rectangular faces are not parallel. See, if you make the light to pass through the other face, imagine you are putting a light from the other side of the board. It falls to this face, this one. It falls to this face. It undergoes refraction, comes out and moves like this. Say this is one beam of light, right? Say, okay, a ray of light is made to pass from the other side of the prism, enters into this face and comes out. Then which rectangular faces you have used for refraction? Light knows now only 2 faces. One is this one and another is this one. This face here, this rectangular face. So it has passed through 2 rectangular faces, and they are called refracting faces. So one is this face, this rectangular face which we have used for refraction. Another is this rectangular face that is used for refraction, and these 2 rectangular faces are called refracting faces. So 1 and 2 here, they are called refracting surfaces. And you can use the other pair also, no problem. You can invert the prism and you can use this rectangular surface and this one. That is left to you. But at a time you can use only two rectangular surfaces. They are called refracting surfaces. And how much angle these two refracting surfaces will create, that is this one. Am I right? The other one inside the board and the first one outside the board. That is called angle of the prism. So if I can draw it again in a different diagram like this. So if the prism is like this, light passes through this face from the other side of the board and comes out from this face, comes out of the board. Angle made by these two surfaces is called refracting angle of the prism. Suppose you take a light and put it to this surface and let it pass through this surface out, then this will be the angle of refracting angle of the prism. That depends on which face you use. But usually prism will be constructed in such a way that one of the face is made very rough. Say this is made rough. Translucent. What do you mean by translucent? The window glass that you have in your house is a translucent. It is neither very transparent nor very opaque. It allows a little bit of light, it scatters a little bit of light into the room. It is not a perfect object which allows the light completely. It doesn't allow the light completely. At the same time, it doesn't block completely. It allows some amount of light to pass through. So such a translucent surface will be usually given in a prism. There is no guarantee. Some prisms allow the light to pass through all the three rectangular surfaces. In some of the prisms, this is made rough. That is called base of the prism, right? Base is that refracting surface which is not used for refraction. That is called base of the prism. And if you keep the prism over this, and if there are any scratches here, anything, of course that won't disturb you, because you are always using this surface and this surface for refraction. So rectangular surfaces used for refraction are two, and angle between the two refracting surfaces is called angle of the prism, and this is called base of the prism. Okay, and now in 3 dimensions the diagram is like this, but every time we can't draw a 3-dimensional diagram, so you will have to have a very simplified diagram. So what we will do is, any prism is taken as a 2-dimensional picture in our paper. So we turn the prism like this. If you turn the prism like this, you take the prism like this and turn it and see it like this. What you will see? You can see only this triangular face. You can see this triangular face when I look from here. So if you are looking towards the prism from this side, you can see only this triangular face. Now when you see this, and if I turn it to your side like this, and you can't see the other faces, so it will look like this, correct? It will look like this. The prism will look like a triangle. This is called principal section of the prism. That is principal section. What do you mean by principal section? Of course, it's not a definition, just you must know it. You cut the prism. You take a knife, as if you cut a cake, cut it here. What you will get? You will get a triangle-like shape like this, right? You will get a triangle shape like this, and the face which you cut will be a triangle shape, right? If you take a banana and cut it, you will get a circular cross-sectional surface in the same way. Or if you cut a chalk like this, what you will get? You will get a circular face. Similarly, if you cut it like this, you will get a principal section which is like a triangle. It is actually a prism. So if I take the prism like this, if I turn it like this, put it into the board, it will look like this. Am I right? It will look like a triangle like this. This is the principal section of the prism. Now, how does this ray of light incident on the face which is inside the board coming out here like this, how does it look like? So a ray of light incident from the other face coming forward and coming out like this. It looks like, so when you turn the prism like this, it looks like this. It is moving like this, and like this. Of course, you must be ready with your paper and pen now. All these definitions are only for your understanding, your knowledge. Won't be asked for the exam. That doesn't mean that you shouldn't study. You should study this. What is the angle of the prism? Angle made by the two refracting surfaces. How many faces or how many surfaces a prism has got? 5. Out of them, 3 are rectangular like this, and 2 are triangular. This face and this face. Triangular faces are parallel to each other, but not the rectangular faces. Rectangular faces make an angle, and the angle made by the 2 refracting rectangular faces is called angle of the prism. And Cross section of the prism will be a triangle shape, and so all these things you must know. Now take a pen and paper, okay? Be ready with pen and paper. Run away, run to your room and bring a pen and paper. We have to see how the ray of light undergoes refraction in a prism. Now onwards we will take only the cross section of the prism, okay? Only the cross sectional view of the prism. So you have to draw enough large diagram. Take a pen and paper. Again I insist you to do that. Otherwise you can switch it off. You can switch off your mobile and you can sleep. That will be better because you will get at least a rest, right? You will get a little bit of rest. So take a pen, take a paper, start writing. Now we are going to derive one equation which is very important regarding prisms. We will take a prism, enough large diagram, not a very small diagram. Say this is the base of the prism. That means where are the other faces are? Here is a rectangular face like this. So here is a rectangular face. And here is a rectangular face. Here is the base. And you can see only the triangular face of the prism. The triangular face here you are looking into. Now I will take a ray of light, put it into this face, right? There is a face here. It gets in and undergoes refraction like this. That is what you have to show. So we have to show one by one. These are the two rectangular faces. The rectangular face is here, right? Rectangular face is here. Triangular faces are not used for refraction in a prism. Why? Because triangular faces are parallel to each other. You find very hardly you find the refraction or dispersion there. You have to get the two surfaces which are making an angle of the prism. You have to mark it. So as I mark it, you should keep on writing, because this is the first time you are learning, right? And this is a long derivation. Long in the sense in between you will get some explanations. You have to do that. Again you have to go for mathematical calculations. So one by one. Lot of physics, lot of mathematics. Geometry. Okay. Now we will take a ray of light. Okay, I will call this as A, B, C. A itself is one corner, one vertex. At the same time it is angle also. A is the angle of the prism, angle made by the two refracting surfaces. BC is the base of the prism. Take a ray of light now. Make it to fall on one of the surface, say AB. So it is like this, three-dimensional imagination you should have. Now take a ray of light, let it fall on one surface. We will name the rays later. Now if you want to know what is the angle of incidence and angle of refraction, you must have a normal, perpendicular line. So let me draw a normal drawn to the refracting surface. Let this be the normal. Can you see this normal? Blue color in green background. Can you see this? I think it is visible, right? Yes. Okay, draw a normal. Usually, where do you draw the normal? Normal is drawn at the point where ray hits, right? One thing. To what you draw the normal? To the surface which is undergoing, where the ray is undergoing refraction. Correct now? So normal is drawn to the surface, this surface, where the ray touches the surface. Okay. Now, say this is a medium of refractive index N1 with respect to air. This is not air now. I don't know. That may be anything. Say a glass prism is put inside water. Then this is water, this is glass. This refractive index of water with respect to air. Refractive index of glass with respect to air. What is the refractive index of glass with respect to water? That is N21. That we know. Okay, let it be. These are the refractive indices of the two media. Okay. Now, say this is rarer, this is denser. When a ray of light travels from rarer to denser medium, its velocity decreases, it bends towards the normal. Sir, how do we treat it as towards the normal? You see the original direction. You take the original direction of the ray, you continue this ray, let it be a straight line. That is the direction it would have traveled if there was no prism. In the absence of the prism, the ray would have traveled straight like this. Am I right? The ray would have traveled straight. Because of the prism, it has to bend towards the normal. That means it bends like this. Am I right? Arrow mark, very important. Now indicate the angle of incidence and angle of refraction. We have to stick on to the definition, okay? Only definition. Angle between incident ray and normal. This is I. Angle between refracted ray and normal, angle of refraction, are 1. Okay? Because we are going to have one more angle of refraction. Okay. Finished? Hope you are following. I give enough time to do enough time to draw the diagram. So a ray of light incident at some angle I don't take I1, I2 because I have a different symbol here. And it undergoes refraction, it bends towards the normal since it is denser compared to this. And once it bends, okay, I will use the same color here also. Once it bends towards the normal, you can define what is the angle of incidence and refraction. This is I, this is refraction angle. Now, the ray moves from denser to rarer. There is one more phase. After passing through the glass prism, say, it comes out. So how to find out the refraction there? Now it is moving from denser to rarer. So draw a normal once again. I'll use the same normal to this surface. So it may be somewhat like this, right? This is the normal. Let these two normals join. So you can join them. Let them join. Okay. This is the normal. Okay, this is the original direction. Of course, this original direction is of not much importance for me, but still I'll draw it. Now, in order to find out that ray is moving from denser to rarer, it should bend away from the normal, right? Away from the normal. This is towards the normal. So, away from the normal is like this, correct? It bends away from the normal. So, here the normal is this one. Bends towards the normal. Here, denser to rarer. Normal is here. If it had traveled like this from the original direction, it would have been towards the normal. Now it should be away from the normal. So away from the normal. Now this normal is not required for us. Just to understand that it has bent away from the normal. From the original direction, it has bent away from the normal. Now I call this angle as emergence, angle of emergence. So E is angle of emergence. We didn't use this symbol till now. Angle of emergence. It has come out with the emerging angle. Now, the ray has bent 2 times, once here and another time in the second surface. Okay? Hope you are writing it. Again and again I remind you, don't look into the mobile or PC or any screen simply by sleeping or keeping yourself in a very relaxed version. You be alert and write it. Otherwise it's waste. Okay, right. Now how do you call this angle as, sir? This is the angle of incidence for this surface. But I don't call it as angle of incidence. I will call it as angle of refraction only. It is R2. For me it is R2. Sir, why do you call it as angle of refraction? Is it not angle of incidence for this surface? Yes. There is no rule that you have to indicate angle of incidence with I only. You can take any symbol. But why did you indicate it like this? Again, principle of reversibility. If light was made to move like this, of course, if the light is made to fall like this, it will move like this. Suppose light was made to reflect back using a small mirror, need not be drawn, this one. It would have reflected back in the same path but in opposite direction like this. Suppose you had taken the ray from here like this with the angle of emergence E, then the ray would have undergone angle of refraction here, right? If you had incident ray of light like this should have been the refracted angle. So every time for each surface we can take the other way also. Put the ray of light like this, it undergoes refraction here. Put the ray of light like this, it undergoes refraction here. For example, if I take a numerical example, imagine this is 30 degree. The ray of light goes like this and comes out at 50 degrees, say. Suppose you put a ray of light at 50 degree here, definitely it will come back with the 30 degree here. It is the principle of reversibility. So whether you take this surface or this surface, take a ray of light like this, put it like this, it will follow the same path as if it was going like this. So there is no difference. Right. Now, so we have marked angle of incidence, refraction and angle of emergence. So you can take the ray of light like this way also. This is not needed. Now, what is the total deviation for the ray? The ray was traveling like this, but now it is traveling like this because of the prism. Due to the passage of light through the prism, finally its direction is like this. You are walking, you are eating something and you are walking in the road. Suddenly you happen to see your teacher, you change your direction. What is the deviation? Deviation is from original direction to the final direction. That is angle of deviation. So your deviation in the road may be 30 degree because you want to escape from the teacher. Maybe 90 degree, you may go to the other side of the road. Sometimes maybe 180 degree, you may return back. Suppose the teacher is a very strict teacher, and if you happen to see him, suddenly you may come back. That is 180-degree returning back. So now if you want to indicate what is the angle of deviation, this is the original direction, this is the final direction. You bring the final direction back like this. You bring it back. So the ray which was traveling like this started traveling like this. So shall I indicate this as the angle of deviation? It is the angle of deviation. So I will mark it here. This is the angle of deviation, and I call it as delta. It's a special symbol now. I don't call it as D. I will use the capital D symbol for another particular case. So what is the angle of deviation? You go along with the definition. Very simple. Don't by heart all these angles, because if you start by hearting, better you take an appointment from psychiatrist. Follow this properly with the theory background. It becomes very easy. For what is deviation? Deviation is not measured with respect to normal. Deviation is from original direction to the final direction. Original direction is like this. Finally it is moving like this. How much it has bent? This angle. And if you bring it here, this is delta. And no definition is required for exam, but you must know it. So incident angle, normal. Refracted angle, normal. Here again, if you put the ray of light like this, that is angle of incidence. That is called emergence. Of course, if it is like this. If this is like this is emergence. Whatever it is. And angle between the original direction and final direction. Now we will name this. Keep on naming this. Ray PQ RS. Okay. A ray of light PQ undergoes refraction along QR, final emerges along RS. And here one thing you can observe, that ray always bends towards the base. Wherever it undergoes refraction, its bending is always towards the base. First bending towards the base, second bending towards the base. So ray of light incident on a prism at some angle keeps on bending towards the base. It bends towards the base. Okay. Now, shall we name this as N? Okay. And Mn, something like Ln. I don't exactly know what is written in NCERT book, but you can follow this. I will name this as some T like this, right? PQT, some Z like this, right? Simply for my convenience. So a ray of light incident along PQTZ, once it enters the prism, undergoes refraction along QR, finally emerges along RS. You have to write a little bit of explanation, not simply derivation. So take a prism of angle A ray of light incident along PQ undergoes refraction along QR and finally emerges along RS. I is the angle of incidence, E is the angle of emergence, R1 and R2 are the angles of refraction. Delta is the angle between the original direction and final direction, that is the angle of deviation. A is the angle of the prism. Okay, name all the things. Now, my job is, so what is the derivations are here? My job is to get a connection with the N1, N2, and angle of incidence, angle of refractions, R1, R2, angle of emergence, and angle of the prism, angle of deviation. All these must come in a formula, not a single formula, but you should try to get the relation between all these things. Angle of incidence, refractions, emergence, angle of the prism, angle of deviation, N1, N2. These must be connected one by one. This is a peculiar type of derivation where final answer itself is not the only thing which is important. It is also important. Some formulas which you get in between the derivations are also very, very important for problems. Okay, now let us apply some of our geometry. Once the diagram is ready, hope you are ready with the diagram, we will move forward, right? You are right? You are ready? Right. Yes, we will move. Now, let us try to get the relation between, first, this is easy, that's why we are starting with this, R1, R2 and A. This is very easy to get. How is it easy, sir? You see, this is a normal, right? This is a normal drawn. And you take the quadrilateral AQNR. In this quadrilateral, already these two angles are 90 degrees. Can you see that? Because this is itself the normal drawn by yourself, and there is no hesitation that this is 90 degrees. 90 plus 90, 180, correct? In a quadrilateral, AQNR is a quadrilateral. The four angles are A, N, and this 90 and this 90. Already 90 plus 90, 180 is finished out of 360. Sum of the angles of a quadrilateral must be 360. Already 180 is finished. What should be the remaining? So it should be 180. So in the quadrilateral AQNR, I don't write all the sentences. So in the quadrilateral AQNR, this is 90, this is 90, 180 is over, A plus N, remaining should be 180, totally should be A plus, totally it should be 360. QNR, angle QNR, angle A plus angle QNR must be 180 degrees, one formula, right? Very easy. Some of the angles of a quadrilateral are 180 degrees. So that is finished. Okay, then you take this triangle QNR, R1 plus R2 plus N must be equal to 180 because some of the angles of a triangle are 180. So in triangle QNR, yes, in the triangle QNR, angle, what I can write, RQN, sorry, I can write R1 plus R2, this R1 plus R2 plus this QNR plus angle QNR must be equal to 180. So you have two equations in which the right hand sides are equal, 180. So why can't you compare the left hand sides? So let us compare the left hand sides. A plus QNR, left hand side of the first equation, left hand side of the second equation, R1 plus R2 plus QNR. QNR gets cancelled. What you will get? Angle A is equal to R1 plus R2. I will simply write A because it is angle A itself. This is the first equation that you get, and let me name it as third equation. So now what did you get here? Simply don't by heart the formula because that won't serve the purpose. See what relation we have got. All the angles of the prism inside. What are the angles of the prism inside? One is angle of refraction, one refraction 2, and angle of the prism. These three angles we get inside the prism. The angle of the prism must be the sum of the two refracting angles. You can easily remember it. Sum of the two refracting angles inside the prism is equal to angle of the prism inside. So A is equal to R1 plus R2. All the things come inside. Of course, delta you can name it here also, no problem. That's not a very special one. So angle of the prism is sum of the two angles of refractions which appear inside the prism. Of course, that is only for convenience I have told. So A is equal to R1 plus R2. Suppose this is 20 and this is 30, sum of them 50, this should be 50 degree. Okay, now we were able to get these characters in our movie. Now where are these characters? Delta, I, angle of the prism. Let us try to bring these characters into the picture now. How to bring this? Where is delta? Delta is here. If I want to connect delta and I and E, see this delta is the exterior angle of this triangle. Am I right? I will name it like this. I will draw a separate diagram. You need not darken this one. You see this triangle here. Is this delta exterior angle for this triangle? It is the exterior angle, right? Now, if you want to know what is this exterior angle is equal to, it is the sum of the interior opposite angles. Am I right? These two. Can you see that clearly? Right? So, this is the ray and this is the original direction, this is the final direction. Don't make it solid. Just for the explanation I am doing so. Let it be dotted line only because this is not the ray. It won't continue like this. And this is also not the ray because we have made it to come backwards. So, in the triangle TQR, delta is the exterior angle. It should be the sum of the two interior opposite angles. So, shall I write delta is equal to exterior angle delta is equal to sum of the two interior opposite angles. What is that? TQR plus TRQ. TQR plus angle TRQ. Right? In this triangle. Exterior, sum of the interior opposite angles. Now, what are TRQ and TQR? TRQ and TQR. Now you can bring I and R. How, sir? See, normal straight line, correct? And this is the original direction which is moving like this. So straight line, straight line, straight line. Vertically opposite angle is here. Can I mark that vertically opposite angle, this one? So can I name this as I, vertically opposite, because this is a straight line, this is a straight line. This is I, this is vertically opposite, full angle. But we are in need of TQR. TQR means only this angle, one of the interior opposite angle. This is this one. What is this one? This full angle minus this angle, R1, angle of refraction, angle between the refracted ray and the normal, R1. So remove R1 from the total I, which is opposite to this, right? I minus R1 is this one. So shall I write it here? Angle delta is equal to I minus R1. Hope you have followed it. It is very simple. So this TQR is equal to total I minus R1. Why this is I? It's vertically opposite. Plus, what is TRQ? Similarly, you see TRQ. In TRQ, this is interior angle, one of the interior angle, that is TRQ. It is equal to, see, straight line. This is quite made to move backwards in order to find out delta. So this is a straight line, this is a straight line. So shall I treat this as E and this as E, right? This whole angle, because vertically opposite, this is E. E minus R2, right? R2 will give you this one. So E minus R2. Hope you have followed, right? Our diagram, after drawing so many things, it has become so ugly that you can't follow. So it is like this. Okay, it's like this. This is R2, so this is normal, and this is R2. Okay, white color, yes. And this is one of the interior opposite angle to delta. This is delta, and corresponding to this angle. This is one of the interior opposite angle, and I want full E, which is opposite to this, minus R2, that gives this angle. Okay, now club this. What is delta? Is equal to I plus E minus, I will club this because already I have an equation which is R1 plus R2 equal to A. So I plus E minus of R1 plus R2. Is it okay? I will skip one step. I plus E is okay. Minus R1 minus R2. Can I write minus R1 minus R2 as minus of R1 plus R2? Because if you bring this minus, it is okay then. Minus R1 minus R2. Because I know what is R1 plus R2. A. So what is delta? I plus E minus A. So very simple, right? It is not over. This is also very important. So angle of deviation is given by delta is equal to I plus E minus A. You have to add the angle of incidence, angle of emergence, subtract it from the R1, R2, that is A, R1 plus R2. So this is angle of deviation. Now, here you have to do an experiment. We will come back to the diagram. Now, so this value of delta, this value of R1, this value of R2, this value of I, and this value of E, they may be anything. There is no restriction that it should be this much and that. You can put the ray of light at 30 degrees, 40 degrees, 50 degrees. You can select any angle of incidence, no problem at all. Now, but there is a group of values. I will take some odd examples, numerical examples. Say I have put a ray of light at an angle of say 30 degrees. I put it at 30 degrees. Okay. Say 50 degrees is the angle of emergence, say, simply. Now, so 30 degrees is the angle of incidence and 50 degrees is the angle of emergence, okay? Then say delta, it is say some 15 degrees. Simply, for our convenience, I am taking these values. 15 degree is the angle of deviation, simply. Now what happens here is, sir, if I increase the angle of incidence, what happens to this angle of deviation? That is my question. You take a ray of light, put it at some more angle like this. Same color light, but at more angle, say 40 degrees. Sir, if that moves with some other angle like this, so what will happen to the deviation? That means its nature with respect to the original direction. What is the angle, sir? This deviation. Deviation decreases. That is a very important thing. As the angle of incidence is increased, angle of deviation goes on decreasing. What do you mean by that? The ray comes closer and closer to its original direction if you choose more and more incident angle. Very, very interesting now. As the angle of incidence is increased, angle of deviation goes on decreasing, and the ray comes very closer and closer to the original direction, and that original direction, if it is like this, then the angle of deviation decreases. Sir, will it become 0? Shall I try with such an angle of incidence that this angle of deviation is 0? No, that is not at all possible. Why? Because what do you mean by angle of deviation 0? Suppose if I put a ray of light like this, and it should bend in and move in such a way that the ray must be parallel to the original direction. No deviation, only shift, lateral shift. A ray of light should be laterally shifted. That is not possible here. Lateral shift will be obtained only when the two refracting surfaces are parallel. If the two refracting surfaces are parallel, then the original direction and final direction will be parallel. Now you can call it as lateral shift. If the two refracting surfaces are not parallel, you will never get this situation. And if you get this situation here, then the angle of deviation is 0. What do you mean by angle of deviation 0? The ray was moving like this, now it is again moving like this. You were moving like this, and suddenly you happen to see your teacher, you move like this and again go in the same direction. What is your final deviation with respect to original direction? No deviation. Deviation is 0. That will never happen here, because the surfaces are not parallel. Definitely this ray, there is no chance of returning back in the original direction. This is wrong, not possible. Now coming back to the prism. If deviation is not 0, sir, won't it reach to 0 then? No. No sir, I will try it. What I'll do is, I'll keep on increasing the angle of incidence. Shouldn't I get at one case the angle of deviation is 0? Not at all possible. Even if you go on increasing the angle of incidence, angle of deviation, this angle keeps on decreasing. Even if you try for more and more angle of incidence, angle of deviation decreases, 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 and reaches a minimum value, then starts increasing. That is a very strange thing. You feel or you expect that if I try for larger and larger and larger angles, definitely you will get an angle of deviation 0. That means your expectation is, for some angle of incidence, the ray must go parallel to the original direction. No deviation, only lateral shift. Never, it can never happen, because here the surfaces are not parallel, as I explained earlier. For certain angle of incidence, the angle of deviation decreases and it reaches a minimum angle, it doesn't become 0, then starts increasing if you try for still more angles of incidence. And now, let me explain it. And all these explanations you are not going to write in the exam. Simply 1 or 2, 3 sentences. I will tell you what sentences you have to write. Now, I explain it in an elaborate way, so that if the things are very clear in your brain, then you can write it in the exam. Always, when you write an answer in the exam, whatever you are writing, you must know beyond that. Then only you can write it with confidence. Suppose you know that much only what you are going to write, you will forget it. You must know, you must be a master of what you are writing. You must know more than what you are writing. So we will see, analyze it in all the ways, then write whatever is needed for the exam, that's all. But you must know more than it. Okay, so let the ray of light in incident, let this be a pair. I'll write this one here. Angle of incidence, angle of emergence, and angle of deviation. What is our pair now? 30 degree, 50 degree, and delta is 15 degrees. Say, simple, odd numbers. Don't try with these numbers. I'm not sure that whether you get, if you put a ray of light at 30 degree for some prism, will you get an angle of deviation 50? No. Simply I have given for understanding. Okay. Now, I will increase angle of incidence. And remember, this set of values here, coming back, I want this diagram also. You have to look into the diagram and this one simultaneously now. This set of values is always true. What do you mean by that, always true? If you take a ray of light, put it from this direction at 50 degrees, will it come back at 30 degrees? Definitely, no doubt. If you take a ray of light, put it at 50 degrees, it will definitely come out at 30 degrees. Now, this becomes the angle of incidence and this becomes the angle of emergence. Now, this need not be done. Sure, shall I put a ray of light in the reverse direction? You need not do that. What you can do is simply change the prism and keep it like this. Whole thing gets reversed. Very simple. Take the whole prism, keep it in the reversed direction. Then this comes here, that goes to the other side. All the angles will get interchanged. angle of incidence becomes 50, emergence becomes 30, R1, R2, interchange their positions. It is symmetrical. So you can call this as angle of incidence, this as angle of incidence, this one as emergence, no problem at all. Okay, now shall I increase the angle of incidence? So one thing here, if I ask the prism, you made the ray of light which was moving like this to bend by an angle of 15 degree, right? It is your responsibility, because of the prism that light was able to bend. The light has bent by an angle of 15 degrees because of the prism. Okay, you ask the prism now, which angle of incidence do you need for this type of refraction or deviation? Sir, I need an angle of 30 degrees. Prism will say, sir, if you put a ray of light at 30 degrees on me, I can produce an angle of deviation of 15 degrees. Ask the prism again. Now it is an interview. Will you produce the same angle of deviation for some other angle of incidence? Can you do that? Other than 30 degree, can you produce the deviation same 15? Prism says, yes, I can produce the angle of deviation 15 degrees for 50 degree angle of incidence also. Because if you put a ray of light like this, or even here at 50 degrees, it comes out at 30 degrees, because it is a set of values. So if the ray of light is incident at 50 degrees like this, or even here, the ray of light comes out at 30 degrees, or even here, if you put it at 50 degrees, it comes out at 30 degrees, deviation is same. Sir, won't be the different angle of deviation you will get? No, never, because when you put the ray of light like this and it comes out like this is the original direction, and this is the final direction, angle of deviation doesn't change. It is the same. So whether it is the 30 degree angle of incidence or angle of incidence 50, angle of deviation is same. Only the original direction and final direction lines will get interchanged. That's all. Angle of deviation doesn't go anywhere else. It is the same. So I can write one sentence here. One angle of deviation can be obtained for two angles of incidence, right? I and E. Both give you the same angle of deviation. Whether it is 30, whether it is 50, so angle of deviation is same. So Prism says, I have a speciality. I can give one angle of bending, one angle of deviation from the original direction for two angles of incidence, one from this side, another from that side, or you can choose any side also. These two are the two angles. Okay, now I will increase the angle of incidence. You know what happens when you increase the angle of incidence? Angle of deviation goes on decreasing. Say I go for 40 degrees or okay, 35 degrees. I'll go for 35 degrees. Now let us say this decreases. Say this is 45. Let the angle of deviation be some 12 degrees. Okay? As the angle of incidence is increased, angle of deviation decreases. Just now I have told. Still increase the angle of incidence. I will go on increasing this one. So this is increased, angle of deviation should decrease initially. Okay, 35. I will make this as 40 degrees. Angle of emergence becomes 40 degrees. This decreases. Angle of deviation decreases. Now you try for still more angles of incidence and you are trying to find whether angle of deviation becomes 0. I will make the angle of incidence 45. Now the angle of emergence, say it is 35. Now the angle of deviation becomes 12. It has started decreasing, decreasing, decreasing. Now started increasing. Sir, why did you write this value? Won't it decrease further? Never, because you see this set of values. When the angle of incidence is 35, angle of emergence is 45, angle of deviation is 12. Can you get the same angle of 12 degree deviation for another angle of incidence other than 35? That is this one. That is what is obtained here. Am I right? When the angle of incidence is 45, angle of emergence is 35, angle of deviation is same. Just now we were saying angle of deviation is one single angle of deviation can be obtained for two angles of incidence, right? One angle of deviation can be obtained for two angles of incidence. So this is the one set. Now I think you can carry on this table. I will increase the angle of incidence further, say 50 degree. Then this comes out at, I think you are searching in the table, right? You are inverting this value. When the angle of incidence is from this side 50, this is 30, this is 15. Did you get the idea? So you will get the same angle of deviation for two angles of incidence. They have just interchanged their positions. But as the angle of incidence is increased, angle of deviation decreases, reaches a minimum value. Can you see the minimum value here? This is the minimum value of angle of deviation. It reaches a minimum value, and then if you further increase the angle of incidence, there is no decrease in the angle of deviation, it increases. So don't expect that the angle of deviation becomes zero. Surfaces are not parallel, they will never become zero. This is the story. Now, shall I call this delta by a special name called dm? What is dm? Out of all the angles of deviation, this is the minimum value. You can't get the angle of deviation in that prism lesser than this. And remember, these are all the numerical values just given for your sake, understanding purpose. Don't write that 10 degrees the angle of minimum deviation, okay? That is not the answer. Just numerically you are given some information. This is the minimum value. So now comes the important point. You have to show all these things in a graph. This is needed for exam, not this one. Don't write this in the examination. Of course, I am very sure that you will never write this in the examination, because writing this part in the examination itself is a question mark. Then writing this part is it is out of my imagination. This is important now. I will write angle of incidence. Sorry, angle of deviation here. Okay, and here angle of incidence. Okay, I have to write it little below because I have to write something else also. Okay, I will write it here. Angle of incidence. So you draw a graph. Of course, here you see, you could have tried for 32 degree, 33 degree, 34 degree, and all the angles. You will get different values of increasing deviation up to here, then decreasing. Those values I have not written. So if you draw a graph of angle of incidence versus angle of deviation, how will the graph, how will it look like? It will be very simple. You know that as angle of incidence is increased from 30, 31, 32, 33, even you can take 10, 12, all those are angles of incidences. So I have taken only one set of values. Now, as I is increased, you know that when I is very less, deviation was more, right? So it starts from here. As I increases, D should go on decreasing. So this is delta, angle of deviation. So it decreases like this. The graph comes like this. Will it decrease, and decrease, the angle of deviation reaches zero? Never. It reaches a minimum value and starts increasing like this. This is the graph. Hope you are drawing along with me. You are not just watching the movie, right? You are just, because don't watch this like as if you are watching a movie. Here nobody, no hero of the film will come. It's the only me who will disturb you for 1 hour. So you have to bear with me. Keep on writing it. That gives you a lot of confidence. Then you will understand when you learn it. Okay, so as the angle of incidence increases, angle of deviation decreases, reaches a minimum value, and then starts increasing. From here onwards, it increases. Now, if you see this graph, if these values, this is the minimum angle of deviation, that is 10 degree, that is for two angles of incidences, but they are same. Correct? So you can analyze this in the graph. How? See, I will see. Sir, this angle of deviation, say it is 15 degrees. Sir, where did you get this? For which angle of incidence and emergence you have got this angle of deviation? When did you get this, sir? You ask the prism. When did you show the angle of deviation 15 degree? When did the ray of light bend by an angle of 15 degree? When the angle of incidence was 30. Is it only for that 30? No, it is also for 50. How it is obtained? This angle of delta is obtained for two angles of incidence, one here and another here. And I call this as I call this as E, angle of emergence, right? So one angle of deviation is obtained for two angles of incidence. You can interchange this. You can take this as E and this as I, or I and I dash, anything. In the book it is given I and I dash, something like that. Now sir, which angle of incidence has given this angle of deviation? It is these two values. Sir, this angle of deviation is given by which angle of incidence? Only one here. This angle of deviation, I call this as dm. It is obtained for only one angle of incidence. Sir, what has happened to the two values here? They have become equal. Can you see this table? This angle of deviation, the minimum value of deviation, has been obtained for two angles of incidence which are equal. So shall I write I equal to E here? They have become equal. So that part is also important. Angle of deviation will be minimum when angle of incidence and emergence are equal. So you have to draw this graph. So, the first part you have to derive A equal to R1 plus R2 in that diagram, and then derive delta is equal to I plus E minus A. It is not a very big derivation, remember, only my explanation is bigger. I am exaggerating everything. Hope you have followed it already. But what you have to write is very less amount of things to write. So you have to derive this, and in between you have to explain. What you have to explain? This much. This graph you have to explain. As the angle of incidence is increased, the angle of deviation goes on decreasing, reaches a minimum value, and then increases. For every angle of deviation, there are two angles of incidence. And there is a minimum angle of deviation for which angle of incidence and emergence are equal. So I and E are same. This is the angle of minimum deviation. Now you have to take this into account. You have to take this into account, and now you have to carry on, right? So shall I write here like this? When, hope you can see this one, when delta is equal to dm, when this value of delta is minimum dm, what you will get? I is equal to E, correct? When delta is equal to dm, d minimum, angle of incidence equal to angle of emergence. And remember, if you go back to the diagram, if these two are same, if a ray of light is put at 45 degrees here, sorry 40 degrees here, what the angle of refraction here you get? If the ray of light is put at 45 degree here, sorry 40 degree here, what the angle of refraction here you get? Should be same. They cannot be different. That means R1 must be equal to R2. Have you followed? If this is same as this one, these two should be same, because same medium here. So this medium and this medium are same. Inside it is prism. So a ray of light incident at 40 degree should move at some angle. This should be, if it is incident at 40 degree, it should move by the same angle. So R1 and R2 must be same. So I will use this condition. Now you have to go to this condition. We will come back to the derivation. So as the angle of incidence is increased, angle of deviation goes on decreasing, reaches a minimum value, and then increases. At the minimum value of angle of deviation, we know, so this is delta. At the minimum value of angle of deviation, dm, this is I and E are equal, and even R1 and R2 are equal. So if they are equal, hope I can write it here. You can see that, right? I will write it here. If they are equal, what happens to these two equations? What is the result of these two equations? So equation 3 becomes, what does it become? 3 is, I will take R1 is equal to R2 is equal to R. Both are same. I1 is equal to I equal to E is equal to I. Both are same. 2R, A is equal to 2R. Correct? What is R is equal to? Implies R is equal to A by 2. One equation. So I will name this as 5. Our number is growing, equation numbers. What about this become? Then delta has to be replaced as dm, because I am going to write I and E are same. So I have to write equation 4 is delta is equal to I plus E minus A, correct? This is equation 4. So how can I write this now? Delta becomes dm, minimum angle of deviation, this one, but at that position I and E are same. So dm and I plus E, I plus I minus A. So finally this is 2I minus A. Bring this A here. dm plus A is equal to 2I. What is I equal to? dm plus A by 2. So we have got I, we have got R. R is equal to A by 2. This we have seen. So this is only at minimum deviation position. So this was 5, already it was written, this is 6. This is the minimum deviation position angle, right? We are coming to the end of the derivation, just one application, that's all. So, why did you get this I and R, sir? What is the use? Just to apply angle of incidence, to get connected with the refractive index. I'll draw the prism, simple prism here. See, you have made a ray of light to fall on this, and like this and like this. This is the normal you have assumed. This is the normal here. I, angle of emergence, R1, R2, right? And N1, N2. And this is A. And our aim was to get the relation between N1, N2, R1, R2, angle of incidence, emergence, and angle of the prism. We were able to connect all these things. R1 plus R2 is equal to A inside the prism. Delta, okay, delta. Delta is the angle between the original direction, final direction. This is delta. Delta is equal to I plus E minus A. This plus this minus A. So I, where is I? I have not written. Okay, I will write. I plus, here it is. I plus E minus A, that is delta. We were able to get, and we are able to arrive up to this using the minimum deviation condition. Now where are these two? Haven't come, right? Still, hero and heroine has not arrived in the film, so you have to bring them. How to bring them, sir? Very simple. Refractive index into sine of the angle. Refractive index into sine of the angle. But not in any other position, it is in the minimum deviation position. So shall I apply this? I think I can write here. Yes, N1 sine I is equal to N2 sine R. Correct? N1 sine I is equal to N2 sine R. I'll bring a chalk. Okay, yes. And what is I? I is A plus dm by 2. This is I. And sine I by sine R is equal to N2 by N1. And you know that this is N2 and refractive index of the second medium with respect to the first medium. Right? Refractive index of the second medium with respect to first medium, that is N21. So shall I write it as N21 is equal to sine I is here, I think our whole board is available. I is equal to A plus dm by 2 divided by, it is this one only by 2 by sine R. What is R? R is A by 2. Here is it. Sine A by 2. See, while writing this should be very important. It is not sine A plus dm by 2. It is not like this. You are not dividing sine theta by 2. It is sine theta by 2. It is sine A plus dm by 2 and sine A by 2. Okay? So, this is the derivation that you are expecting, like this. So, refractive index of the prism, this one, second, with respect to the surrounding medium is equal to sine of the angle of the prism plus angle of minimum deviation by 2, sine divided by sine of the angle of the prism by 2. So, sine A plus dm by 2 by sine A by 2. Very important one, but as a whole it will not be asked for the exam. It will be asked and you may be asked to assume the equations like R1 plus R equal to A and delta is equal to I plus E minus A and all. Sometimes it may be asked to derive only up to delta is equal to I plus E minus A, something like that. But when you learn, be ready with the whole derivation, right? Very, very important one. Then we will move to the next part in the next class, okay? So this one is very important. The last one, the mathematical steps. Hope you have followed all these things. Here is only the Snell's law we have applied, okay? Study this, and if you have any doubts, again, you know this one, right? If you have any doubts, you just put it in a paper and message to 94801 98001. Okay? Shall we meet in the next class? Thank you.